Permutations with cases. Sometimes you can't count all of the things all at once. And so you have to count it in different steps. You have already done some of these questions already without knowing it. Do you remember on the homework question where it said consonant vowels must alternate? And you did consonant, vowel, and got 24, and you looked at the answer and it was 48. And some of you came and asked questions and said, oh, did you consider you could start with a vowel? And that would be an example of cases, because you count one case where the consonants are first, and then another case where the vowels were first, and then add them up. So we have this as a whole strategy. When you can't count something all at once, you count different cases, and once you've counted all the different cases, you add them up to find your total. So how many digits of at most 3 different digits can be formed? So the way we realize this as cases is sort of like, oh, I could have a 3-digit number, a 2-digit number, or a 1-digit number if I was counting a 3-digit number. Okay? And we're going to put here no repetition, just to add that in there. And again, I'll be explicit on quizzes and tests whether or not you can repeat. Sometimes the situation says you can repeat or not, like license plates, postal codes, those are things that you could repeat a digit or a number on. So case 1, 3-digit number. Do we have any restrictions? Right. So there's a restriction on our first digit that it's not 0, leaving us with only 9 choices. Then we've used up a number. How many choices do we have left? 9 left. And then we've used up 2 numbers. There are 8 choices left. $648 total. Questions about that so far? Well, there's 10 digits, including 0, right? The first one can't be a 0, so you have to take 0 out, leaving you with 9 choices. Okay? Let's say you pick the 2. Now the 2 isn't available for the second one, but the 0 goes back in. Case 2, we haven't counted 2-digit numbers. Again, not 0. 9 choices there. 9 choices because you can put 0 back in for 81. And case 3, one-digit numbers. Is 0 a 1-digit number? Yes. So here you'd have 10 choices because it could be 0. Add them all up for 739 different numbers of at most 3 digits where the digits aren't repeating. The 1-digit number could be 0. That's why there's 10 choices. So we get these cases questions, and probably the most typical place that you get a cases question is something like this. How many 3-digit numbers can be formed using 1 to 5, no repetition, that are greater than 300 and even? This one has 2 conditions or 2 restrictions. If you tried to do it in one step, don't write this down, but if you tried to do it at one step and you said, I have a restriction, my first digit has to be a 3, 4, or 5, and I have another restriction, my last digit has to be a 2 or a 4, what number do I put in my first space if I deal with that restriction first? 3, right? Because I have 3 choices. What number do I put in my last one? Is it always 2? 2 or 1, should you put 1.5? Or is it 1.33 because like the 4 only, you can't do it because you don't know. In my 3 choices, I might have picked the 4. Then I can't pick the 4 here. But I don't know if I picked the 4 or not. That's a problem. So what we do is when we have 2 restrictions and there's something that overlaps in those restrictions. The 4 is in both of those restrictions, causing us a problem. When that's the case, then we use cases. So how do we use cases? Well, we take one of our restrictions and split it up, right? We could say, let's look at, since my last restriction has only 2 choices, I'm going to split up my last restriction. I'm going to look at case 1. I'm going to count all the numbers that end with a 2. Well, if it ends with a 2, I only have 1 choice. Now, my other restriction, how many choices would I still have for my first digit? It could still be 3, 4, or 5 to be greater than 300, giving me 3 choices. And then for my last decision, how many numbers do I now have left? I've used up the 2, and I've used up either a 3, 4, or 5. I have 3 numbers left, giving me 9 choices, 9 total options. Case 2, what haven't I counted? I have to end with a 4. One choice. Now for my first digit, and this is why it's important to write out your restrictions underneath as a little bit of explanation, because then you'll realize, oh, I used up the 4. Now I only have 2 choices left here. I've used up 2 numbers. There are 3 numbers left. To get a total of 15. Now, so when we have 2 restrictions and there's an overlap of the restrictions, we're going to use cases. And when you decide to use cases, choose one of your restrictions, it won't matter which one, and break it up. You could have made this a question with 3 cases. Case 1, start with a 3. Case 2, start with a 4. Case 3, start with a 5. You could have made this something with 2 cases. Here, I'll just do it. If the 4 is the problem, start with a 4. Well, if this is a 4 here, 1 choice. This has to be then, to make it even, the only even number left is a 2, 1 choice. I've used up the 4 and the 2. I have 3 numbers left for 3 total. Case 2, I could have started with a 3 or a 5. I don't have to break those up because they're the same thing. They have no restriction. If I use a 3 or a 5, I still have 2 options of a 2 or a 4 left. You used up 2 numbers, 3 left in the middle. Still gives me 15 in total. So when your restrictions overlap, and you have more than 1 restriction, and you have to use cases, Then you break things up according to your restrictions. And just doesn't matter which restriction you pick to break it up. Okay, part B, still using the numbers 1, 2, 3, 4, 5. We want numbers greater than 232. Technically, this question has only one restriction. The last one said greater than and even, which gave us restrictions on more than one spot. Greater than questions do have some problems too, because if I try to do it like this, this is my only restriction, right? It has to be greater than 232? Maybe. How many choices could I have in here? For sure 3, 4, and 5. Could I start with a 2? Then when I get to spot 2, we have a problem. Why is there a problem here? Because if it's the 2, I don't have as many choices. But if it's the 3, there's no problems, right? So on these questions where it's greater than, start with your case 1. What would you have to start with to ensure that it's greater than? If you start with a 3, a 4, or a 5, it doesn't matter what happens after that. Those will count your numbers in 300s, 400s, and 500s. For sure they'll be bigger than 232. So you start with what would guarantee that it's bigger. 3 choices. Now we've used up one number, no restrictions left, so we have 4 choices left. We've used up 2 numbers, 3 choices left for 36 in total. Case 2. What haven't we counted? We didn't count any numbers in the 200s. So if I start with a 2, and then when I go to my second digit, I say, what would guarantee that it would be bigger than 230? Well, if I started with a 2 and then did a 4 or a 5, that would count my numbers in the 240s and 250s. So again, we write our 3 spaces. We said this for sure is a 2, one choice. This one is a 4 or a 5, 2 choices. And then there would be no restrictions on our last digit, 3 left. What haven't we counted? There could be numbers in the 230s that are bigger than 232. So case 3, start with 2, then 3, then what has to be our last digit? It has to be bigger than 232. What choices do we have left? Well, we don't have 3, 4, and 5 because 3's already been used. So then just 4 or 5. 200s, 230s, and to be bigger than a 2, it'd be 3, 4, or 5, but this is why it's nice to write them underneath. You see, I've used up my 3 already. All I have left is a 4 or a 5. 2 choices. Add up all your cases. Used to be on the final exam, they would always give 1 mark for adding up your cases, even if your cases were extremely wrong. You had done no math right, but you added in the end, and you got a full mark for it. Lately, they've taken that away. Oh. Sometimes you still get a half a mark for adding it up. So we add up our cases to get 44 in total.